Well, if there's one thing I've learned this semester, it's how to make a really killer slide on ChatGPT. I had fun with this one. I hope you enjoy it. Today we're going to talk all about Docker, and before we get into the commands and some of the technicalities of using Docker Desktop, I want to go over the reason why Docker became so common and popular in the first place. Docker is not just another development tool. This is more like an overarching developing methodology. It solves the problem, this age-old problem of my software worked on my computer, why won't it work on your computer? And most people who have written code over any length of time have run into this problem at some point. The script works on my laptop, but when I bring it to work, it doesn't run on the Linux system in production. Maybe the Python notebook works in the cloud, but then when I bring it down for some debugging on my MacBook, everything's different and the hardware and the software doesn't interact correctly, the codes don't run, and your workflow doesn't stay intact. Most commonly, this is because we're developing locally on our own computer, but in production, it goes on a server that's usually Linux, and things just work out a little bit differently. And Docker gives us one way to solve this problem. Instead of only sharing the code, such as in a Git repository, Docker lets us share the code plus the entire environment needed to run that code for consistency and stability. That environment can include things like the operating system, libraries, Python version, installed packages, command line tools and scripts, and a working directory of files needed to get up and running and run your container. When we package all of those things together in one place, we call that the Docker image. And when we activate and run code in the image, it's called spinning up a container. So we run code in Docker containers for that stability and repeatability we're looking for. A container is not exactly the same as a virtual machine, whereas a virtual machine usually includes a full guest operating system. It's a heavier computational load. It's heavier start, it's slower, and it's more resource intensive because it includes the entire operating system replicating a hard metal computer. A container is lighter, so it's more convenient. It shares the host's system kernel, but it runs an isolated user space in that environment. It makes a container fast to start, easy to copy, and easily reproducible across machines. Docker uses containerization to package software into standardized units that include the code and dependencies to run different environments. And that distinction matters. In traditional analytics work, we'll often focus on the code. That's the Python notebook, the model, maybe the data set, and a handful of inputs and outputs from some kind of a coding script. But in professional settings, the environment matters just as much as the code. The version of Python matters immensely. The version of TensorFlow matters as well. The operating system and the GPU support matters for this reproducibility from system to system. Even the directory structure and the file paths are going to make a big difference in this repeatability and reproducibility that we can actually achieve in Docker containers. One of the last things I want to mention as we transition from the lecture material to the class activity is Docker is a great way to move your developing and debugging environment on your local machine into a production run on the cloud. Docker has great compatibility with a lot of cloud enterprises such as Google Cloud Platform and Amazon Web Services, just to name a couple. Most servers offer some type of Docker interface. So as an example, I have this script, which came from the Keras examples, and it runs well on my computer. What's really cool is I want to containerize it and make it portable to run, whether it's from my computer, a friend's computer, maybe even a different operating system, or also on the cloud. So I've installed on my computer this application called Docker Desktop. Docker Desktop gives us all of the command interface tools to spin up an image and run it as a container to execute the code. All right, you Docker ninjas, We've talked a lot of big picture concepts, but it's a little bit tough to see how they fit together, so I'll go through one by one. As you get started, you're going to want to choose your source image, and you might find it by browsing the Docker Hub website and pick an official Docker image because you know it's safe and secure. For example, you might want to use a Docker image that runs Python 3.11, 3.13, whatever you know you need for your specific project. Next, you're going to have to do a little bit of setup. The details will come later, but you can create a Docker file and a requirements.txt file to automate all of the setup with dependencies and libraries you need for your project. So if you know you need a specific version of TensorFlow, you know you need matplotlib, that will all be in the requirements file. You do it once and your image will be good to go in the future. Go ahead and use the Docker tool to build the image. It will be saved somewhere on your local machine for future use, and you can share it with your colleagues. There'll be some steps for mounting your files so that the Docker container has access to the files you actually need. You can do that during the setup, and it will be your files will be mounted to the image for future use anywhere you run that container. And then finally, I'll show you how to run the container. I typically run it from the command prompt. And then as the container's running, I'll actually execute my Python code and everything will work exactly as we expect because the container has been set up for this project specifically. Remember, this matters because Docker ensures consistency across machines. It simplifies the setup so it's a one-time thing, and it'll make your work portable and reproducible whether you're on any local machine or even the cloud. What I did for this use case is I went to Docker's website and I searched for the Python image. Now, there's more than one official Python image, and that's important because we want this to be all about reproducibility and compatibility. So what you're going to want to do is click over to this tab section. So this is your blank canvas and your starting point when you're about to do a project using Python in a container. What I did is I knew I wanted to get a version of Python 3.13 for the best compatibility with TensorFlow and Keras in my example specifically. Remember, the versions are the whole point of the containerization. It's going to be the same no matter where you run this container. All right, so like I promised, I want to use Python version 3.13 as the starting place for this project. So I just typed in 3.13 in the tag section of the Python official image. And you may or may not care about the specific differences between each of these images, but what worked for me was the one that just says 3.13, and you can see it was last updated just a few days ago. So as we've decided on this specific official image of Python 3.13 with that specific tag, I'll use the command docker pull python 3.13 to start that pull, bringing this into my local computer in the location where Docker images are saved. It's a little bit trivial in this case because I already have the latest version installed on my computer, but it might take just 30 seconds to a minute for that pull on your version when you try in your own computer. Since your Docker container doesn't inherently contain the files, we just brought the image down from the website and it's on our computer, but there's no files in it. At this point, you might choose to mount files to your image so that it will run correctly as you hit go on your code in the future. But in this case, I'm going to spin up the container with the command that I'm dropping onto the screen. And that's docker run command with a little bit of details to point it to our workspace for this project. We can get into the technicalities later, and you can look up the command on the cheat sheet if you need it. Here we go. And just like that, you can see that our Docker container is up and running because the preface to our command prompt environment changes and shows the root of our Docker workspace. Pivoting back to the Docker desktop app for just a second, I want to show you a few things. In this second tab here that says images, you can see that we've downloaded a handful of images, at least I have downloaded a handful of images, including that one we just talked about, the Python with the tag 3.13, the very specific image that's compatible with that version of Python that we're going to use for this exercise. Then when we click over to the containers tab, we can see that it's spun up an actual container with this silly name and a container ID, and that it might end up using some resources as we run code. I'm going to go ahead and use this command Python and then the name of that Python file. And if you were to make a guess right now what's going to happen, you would imagine I hit enter and the code works just flawlessly because we have the image, we spun up the container, and we're in the right file location. Why won't the code run? Well, the reason the code's not running is because the image of Python that we brought down from the internet doesn't have the packages that we know we're going to need to run this specific project. I'm going to need to do things like NumPy, and that's getting our image closer and closer to the place that we want to be for reproducibility. And that's great, but then there's going to be other packages that we want to run, that we want to download. Keras, so I have to go pip Keras. And we're getting this Docker environment, this Docker container, closer and closer to being the environment where we can run this exact Python script every time perfectly. So I'm not going to go through the details with you of how to get it exactly where it needs to be, but I want you to know that we can make this image just right for this project, and we'll never have to worry about this pip install nonsense ever again, as long as we continue working with this script, these data files on this container. This pip install process is a one-time go, and there's actually a lot of Docker tools that you can use to get that environment where you need to be, but that's beyond the scope of this video. We're going to get to that a little bit in this learning activity coming up. I will take a moment to prove to you that Docker images and spinning up containers are worth the initial setup. So there's this image where I already went through the process of all the pip installs and getting the environment just how I want it to run this script on any computer. And it has this silly Keras Cats Dogs name. And when you spin up that image into a Docker container, and I did that using the command prompt, it generated a new container. So from the image, it generated a container, the actual live environment, and it has this other silly name, Peaceful Borg. It's just randomly generated. But when I flip back to the command prompt, I am all set up in this environment. It already has, in this image, it already has all of the files identified, so I don't have to go through the navigating anymore. That's already done the first time every time I spin up this complete image. And I can do the moment everybody's waiting for, when I can run Python image classification from scratch, that thing that failed before. And from this container, it actually is going to work. It's just a large file, and it's going to take a good minute, probably 30 minutes, to run through this Keras project and train the model. One thing I'll point out is, because this environment isn't set up for GPU utilization, even though the computer has NVIDIA GPU, the CUDA stack isn't live, and this will just run from CPUs in this container. That's part of that reproducibility. Since this container from this image doesn't have GPU set up, it's not going to use GPU. So in practice, even though I was showing a lot of the Docker processes in the terminal, you can do a lot of it from the Docker desktop app. Remember, we just spun up this container called Peaceful Borg from the image Keras Cats and Dogs. Keras Cats and Dogs already has all of our Python packages ready to go, and the files have been mounted to this container. Early on, I mentioned that the container itself doesn't have files, but when you set up the image for the first time, you can mount files to the container so that it can access it while running applications. So I will show you that by clicking on the live container peaceful Borg. What we can see here is the log of Python running that script, same thing that you'd see in this PowerShell terminal. And I told you that we could see the files that have been mounted. I previously mounted all the files to the workspace when I set up the image for the first time. And that's why when you open this image, you can just go ahead and run the Python script without additional setup. It's there ready to go. The other thing I'll point out is this container is taking up many of the compute resources from my actual Windows desktop. Only allocated a little bit of RAM, 8 gigabytes, but its CPU usage is kind of maxing out what I wanted for this specific project. Pull up Task Manager for you, and you'll see that my computer has allocated an enormous amount of the CPU compute just to run that Python script in the container. Just to show you how the Docker container utilizes resources from my desktop workstation, my computer is actually near maxing out all of its CPU and memory to do all of the things going on right now. But most notably, what's going on my computer is running this Python script in this specific container. On the bottom of Docker Desktop, it shows how much sources are used. The amount of RAM is a bit elastic. You can set the RAM allocation when you spin up the container, but here it's growing up to about 14 gigabytes and CPU pretty much maxing out the computer as well. If you have multiple containers running, you could put a little bit of guardrails on that, but I did not in this case. Meanwhile, back in the terminal, you're getting all the updates of the model training from that Python script that's leveraging the Keras package. And it's going to take a while because it's just running on the CPU compute, and there's a lot of training to do on a lot of images. So hopefully that just gives you a little bit of background on how we use Docker in practice. We pulled down a raw Docker image from the library, and we used those tags to get the specific Python environment for 3.13. Then I did some setup. I didn't show all of it here, but we did the pip install and we mounted the data to that image. And then we launched our container from that image, running a live container in Docker. And from that live container we had up and running, we started running our Python script. And because the container was set up really well, the script is running exactly as we want to. And we can replicate that from any computer that has the Docker image and enough compute to train the model. The results should be the same anywhere you do it. So you don't have to take it from me. If you want a real world case study on how Docker container has enhanced the development process for a real world company, in this case, PayPal, I'll share the link to this YouTube video, a story of cultural change, PayPal's 2-year journey to 150,000 containers. And that's their standard practice now, to use Docker containers in their development teams.
Hi, my name is Meghdut. I manage the container platform team at PayPal. And today we are going to take you through our 2-year journey at PayPal, introducing containers for existing applications in our large enterprise. And the challenges we faced, the key takeaways, the strategy, the pitches to our executives. So we'll just walk you through that entire experience.
I'll save the fun for later in the module, but it should be a pretty good learning experience this week, and just reach out if you have any questions.